significant contribution in my work is the co-gasification of biomass. Biomass has a big potential for use. However, there are situations where the amount of certain biomass is so small to be gasified industrially. But with the co-gasification, we are enabling two or more biomass material to be co-gasified, and therefore the one that has no demand or not so popular can still be utilized for gasification. I think that's something that we are proud of, and it's still ongoing. Okay, here what we're having here is known as a waxy crude oil flow loop rig. Okay, it was funded by Yayasan UTP grant by UTP way back in 2013, and what we're having here is an attempt to mimic the situation under the sea. At the seabed, we have pipelines carrying crude oil from the well to the crude oil terminal at the shore. For normal crude oil that has some criteria such as asphaltene and so on, it has tendency to solidify when it is left to cool down. Take an example, when production pipeline is having stop of flow. Suddenly, the fluid is not moving. The coolness of the surrounding at the seabed at around 5 degrees Celsius, for example, is cooling down this crude oil, and because the name is waxy crude oil, it becomes solidified. Fine, okay. The stoppage of production can be due to accident, can be due to some maintenance issues or anything. So we cannot stop crude oil flow from being stopped due to operation. But when we have this stoppage, the solidification is like your cholesterol in the blood. When it's fully occupying the pipe, the next problem would be how do we start the flow again when we are ready to start. So this rig is intended to study the behavior of the solidified crude oil and be able to predict what is the best pressure, best mechanism to restart the pressure. So what you're seeing here is a reservoir or a tank that comprises cold water at about 5 degrees Celsius with some range depending on what we want to study. In this reservoir, we have a pipe section, I call it test section. Depending on the situation, for now you're seeing this as a stainless steel pipe. Okay, the original pipe was acrylic pipe. We try to mimic the situation in the seabed. Okay, we have in this pipe flowing crude oil coming from the upstream of this flow loop. Okay, somewhere here. Okay. Crude oil supplied by Petronas from an undisclosed well that has that feature of waxy crude oil. And to get this flow of crude oil, it got to be heated because naturally this crude oil, because it is waxy, it is very kind of solidified. Okay? So you need to melt it by heating. So we have flow, we'll have a pump down there. Okay? We flow, go back into the tank. During the experiment, what we do is after the flow is steady, we will stop the flow, and this reservoir of cold water will cool down the crude oil. When this section has crude oil that has been solidified, we will take it out into an MRI equipment and talk about that. We don't have MRI. During the start of the project, we had collaboration with USM Subang Krian in Kelantan. So this whole rig was transported to Kelantan, stayed there for about 1 week or 2, and the student with his technician did the experiment with the MRI. So he brought the test section into the MRI to see what's inside the pipe to normally identify the void or the gap or the air void inside it, the sizes, the variation, pipe length, as well as diagonally.